Welcome to Sundar's lecture. This is lecture number 37, and in this lecture we are going to see AC through pure inductor, right? So we are going to give an AC source to the pure inductor and we are going to get what is the power value in this circuit. See what are all the topics we have seen in the last class. We have seen AC through pure resistor. Before that we have seen what is positive power and what is negative power, right? And then we have got what is the value of I, and then we have derived the expression for power, that is V into I. Then we have got this expression, that means P is equal to Vm by 2 into 1 minus cos 2 omega t. Then what we have done, we have just substituted the values of omega t and we have plotted these values in the graph. And we have seen that every power, what are all the things, what are all the by substituting the omega t, what are all the expressions for particular omega t we got, that means values, we have plotted it in the graph. The graph shows that all the powers are positive, which means if the powers are positive, then power would have flown from source to load, which means all the powers in the resistive circuit are real power or active power, that we have seen in the last class. And we have also derived the expression for average power. See, from the graph itself we have derived that we have derived the average power, right? The maximum value minus the minimum value divided by 2, and we have got that it is nothing but Vrms and Irms, which means defaultly you have to understand that in any expressions, if it is a AC circuit, then you have to defaultly understand that it is the RMS values. So P average for the purely resistive circuit, we have seen that it is V into I, right? So now in this class, we are going to see AC through pure inductor. See, before that, we have to know certain things, which means by Faraday's law, by Faraday's law of electromagnetic induction, I am not writing that. Anyhow, see, by Faraday's law, if you are giving, for example, not by Faraday's law, anyhow, by default, if you are giving an AC supply to the inductor, which means if you are giving the AC supply to the inductor, the AC supply is already changing in the value of voltage is already changing with respect to time. So the flux induced in the coil will also change with respect to time. So what is Faraday's law? If a flux in the coil changes, then there will be an self-induced EMF, which is opposite to the cause producing it, that we have already seen, right? That we have already seen those kind of things. We know that. So what is the expression for E here? So I am just writing down what is the expression for E. Simple. What is E? E will be is equal to minus L di by dt by Faraday's law. We have seen this expression already, right? So flux, the rate of change of flux and the rate of change of flux is directly proportional to current. Everything we know that. We already know. So E is equal to minus L di by dt, right? So if you are writing the KVL expression here by KVL, so what is the expression we can write by KVL? See, the current is flowing in this direction. So V plus E will be is equal to 0. So V plus E will be is equal to 0, or we can write it as V is equal to minus E. That we know, right? Whatever the EMF is induced here, that will be opposite to the cause producing the flux in it, right? That is the point we have already know. So from here what we can do, now, see, we can also find V. I am just writing here. So V will be is equal to minus of what is E? E value will be minus L di by dt. So minus L di by dt. So at last what I can write, V will be is equal to L into di by dt. So this is the expression. This is the expression we need. So what we need now, we need to find what is I. So if you want to find what is I, so come here, I am just writing it down. So from here, so you just bring V into dt, which is equal or divided by L, I'm just bringing all this term to the other side, and then I'm just writing which is equal to di. Now what I need to do, I just want to integrate it on the both sides. If I integrate it on the both sides, so it will be di which is equal to integration of v by L into dt. So this is the integration, right? This is the, so if you integrate this one, what you will get? Obviously you will get I will be is equal to, here you see 1 by L will be the common term. I'm just taking it out. So this will be, what is V value? What is V value? That is Vm sin omega t. So Vm sin omega t into dt. In this term, Vm is the common, so I am just taking it out by L is already there. So what is sin omega t? Integration of sin omega t. Sorry, this is not dt. Actually, this is instead of yes, it is dt. So this will be what, sin omega t. If you are integrating sin omega t, so what you will get, minus cos omega t divided by omega, right? Divided by omega. Why this omega is coming? Because I am just integrating this with respect to t. Omega is already there, so you need to differentiate this term in the denominator, right? So you will get like this. So here what I can do further, I can do like this, right? Minus Vm by omega L cos of omega t, right? This is the x. So what we can further do now, so how we can write the cos omega t? Cos omega t will be nothing but sine of 90 minus omega t, right? So what we can do further here, so this is minus Vm by omega L. Here what I can do, sine of 90 minus omega t, right? I can do like this, right? So now what I can do, as further I can simplify this expression by, this is Vm by omega L. I can write sine of omega t minus 90 degree. See, if I change this one, that means sine of 90 minus omega t will be is equal to minus sine of omega t minus 90. So that minus and minus will get plus here. So I will get the final expression like this. This is omega L. This is omega L. See, now I can further simplify this one. I am just taking this as XL. XL will be is equal to omega L. And we know that omega will be is equal to 2 pi f, that this is nothing but angular frequency. We have already seen this, right? So then XL will be is equal to 2 pi f L. That we know this one, right? So I am just taking commonly that this is I expression. This is Vm divided by XL sine of omega t minus 90 degree. This is the expression, right? So what I can do now further I can simplify this value, which is nothing but I am just taking it as Im. I am just taking it as Im. So finally what I can write it down, what I can do, I will be is equal to Im sine of omega t minus 90 degree. So this is the expression for I. This is the expression for I we have found, right? So what is this I? I will be is equal to Im sine of omega t minus 90 degree. What is Im? This is Vm by XL. And what is XL? Which is nothing but XL which is equal to 2 pi f into L. That is nothing but we are calling it as inductive reactance. That means the flowing of current in the inductor will be opposed by this term. That is nothing but inductive reactance. So we are learning that current in the inductor, if pure inductor, if you are giving a AC supply, then that will be I is equal to Im sine of omega t minus 90 degree. What is this minus 90 degree? We have already seen that the voltage V is equal to Vm sine omega t. Then what is the current? The current is lagging by 90 degree. By 90 degree, right? And also we have learnt that inductive reactance of this inductor will be 2 pi fl. or we are calling it as omega L. So these are all the basic things we need to understand. Now what we can do, we just try to substitute these two expressions. Power we try to substitute, or we try to get the value of power now. So for that we will go to the next page and we just try to write both expressions. So now you see we have taken the expression. So V is equal to Vm sin omega t, I is equal to Im sin of omega t minus 90 degree, that we have already derived. But also we can write like this. See, I have just taken it from here. So from here, right? This is nothing but what? It is Im. So cos omega t. So minus cos omega t I have just taken here. So now what we try to do, we try to get the power value, right? So power P will be is equal to what? V into I, right? So if you substitute V, that is Vm sin omega t into this value, this minus, I am just writing it here. So minus, then this will be Im cos omega t. So or we can write like this, minus Vm Im sin omega t, and then it will be cos omega t, right? So if you go for this one, and we know that sin a and if it is cos a, then how we can write this one? Sin of 2a divided by 2, right? So this is the formula. See, this one is like that. So sin a cos a. So what we can do right here, so minus Vm Im, we can write this expression as sin of 2 omega t divided by 2. So finally, what is the power value we can write? So P will be equal to minus Vm Im divided by 2 sin of 2 omega t, right? So sin of 2 omega t. So this is the final expression for power, right? So now what we can do, we just try to substitute all these values in the graph by substituting omega t value, right? So if we are substituting the omega t value, then we will get so many values. So we try to plot that in the graph now. So we have taken the power expression, that is minus Vm Im by 2 sin of 2 omega t, right? So what we have done, so we have just substituted the omega t value in this expression. See, so omega t is equal to 0. So omega t is equal to 0, then it becomes sin 0. So sin 0 will be 0. So everything, the whole expression becomes 0. So at 0 degree, what is the value? This is nothing but it is 0, right? So I have just substitute here. It will be 0. At 0 degree, the value also will be 0. So at 45 degree, it becomes sin 90. So what is sin 90? Sin 90 will be 1. So this will be 1. So the value will be minus Vm Im by 2. So where is minus Vm Im by 2? I have taken this point. So at 45 degree, it will be here. So at 45 degree, so it will come around here. So at 45 degree, it will come around here. So I have just marked this down. Then at 90 degree, the sin 2 omega t, so it becomes 180. So uh, if you get what is sin 180 degree, that will be 0. So it becomes at the 90 degree, it becomes 0. At 90 degree, it becomes 0. Then you just substitute all these values. At 135 degree, it becomes Vm Im by 2. So at 135 degree, it becomes Vm Im by 2, and at 180 degree again it becomes 0. So at 180 degree again it becomes 0, and at 225 degree it becomes minus Vm Im by 2. At 225 degree it becomes minus Vm Im by 2, and at 270 degree again it becomes 0. So it is 0, again it will come here, and at 315 degree it becomes again positive Vm Im by 2. So it will be positive Vm Im by 2, and then it will be at 360 degree again it becomes 0. So at 360 degree again it becomes 0. So I just bring this to here. So now I just need to connect all these points. So it will be like this. So if I connect, it will come like this, and then and then it will be like this. Okay, fine. So now you see this graph is getting negative value at this portion, and then it becomes positive. Again it is getting to negative. In between it comes across zero, right? It comes across zero, then it becomes negative maximum, and then it becomes zero, and then it becomes positive maximum, and then again it becomes zero. See, this power, this I just need to write it down. What is the power value here? See, power value is negative here, positive here, negative here, positive here, which means if the power value is negative, then the load side, the power will be delivered from the load side to the source side, and again the power is delivered from the source to the load under this portion. Positive power. What is positive power? Positive power means the power will be delivered by the source and absorbed by the load. And what is negative power? Power will be delivered by the load and absorbed by the source, and it is going like this. And again you see the power becomes positive, and this will be continued throughout. Then what is these powers? I have already told you, if the power is delivered from the source to load, then load to source, then source to load, then this cycle will repeat throughout, which means these powers cannot be utilized by the load nor by the source. These powers are also called oscillating powers, and we are calling these powers are reactive powers. See, this is nothing but reactive power. Reactive power, right? There is no power in the positive region only. There is no power which comes across only in the positive region. All the powers are, it becomes positive and negative, positive, negative. It is going throughout. So these are all called the reactive powers. And if you are taking average for this, if you are taking average, what you will get? See, at this instant it is getting positive, and at this instant it is getting negative. Negative maximum. See, maximum values are same. This is VMIM by 2, and here it is minus VMIM by 2. And if you are taking the average value, what you will get? What you will get? Obviously you will get 0. Obviously you will get 0. If you average this one, what you will get? See, it is maximum, and it is positive maximum, it is negative maximum. Positive maximum, it becomes negative maximum. So obviously if you go for P average here for this particular sine to omega t graph, you will get 0. You will get 0. Why? Because every powers will get cancelled each other, because it is a positive maximum and negative maximum. So there is no power is real power. If you are getting average power, then that is called as real power. Since there is no average power, every power that this circuit possesses, which means this circuit possesses, is a reactive power. It's a reactive power. Right? Can you understand? This has to be understood very clearly, right? So now, what is my point? The another point, you would have understood this one, right? All the powers are reactive powers. So if it is a pure inductive circuit, then the power in the circuit will be all powers will be reactive powers. That you have to understand. Then, if I want to draw the phasor diagram, so I just want to draw the phasor diagram. So phasor diagram. Right? We know what is V, and this is the this V will be the reference value. So I just want to draw the reference V. See, this is the reference value, right? This is the reference value. I am just writing it down as. So this is V. We know that Vm, it is nothing but Vm sine omega t. It will be sine omega t, right? If I want to go for Im, see what is I? What is I? I will be is equal to Im sine of omega t minus 90 degree. What is the pi value here? It is 90 degree. Try to understand. It will be 90 degree, that too in the negative direction. That too in the negative direction. So how will you draw this one? Very simple. Very simple, right? How will you draw this one? This will be like this. This will be like this. And what is this? This will be I, which is equal to Im sine of omega t minus 90 degree. This is the 90 degree value. And what is this one? And what is this one? What is the angle between these two? Pi will be is equal to minus 90 degree. Or you just write it down 90 degree, that it comes by in the negative direction. If it is a plus 90 degree, then this I will lies like this, right? So this is the phasor diagram for the purely inductive circuit, which means you have to understand one thing very clearly. If it is a purely inductive circuit, then your current lags the voltage by 90 degree. Defaultly, you have to understand that if it is a pure inductive circuit, all inductors will have a current that will lags the voltage by 90 degree. See, we have seen what is lagging phasor in the previous classes, and we are just witnessing that one through pure inductor circuits, right? So, if you are going for a capacitive circuit, that will lies like this, which means that is a 90 degree leading. The current in the purely capacitive circuit will leads the voltage by 90 degree. That we will see in the next class anyhow. So, these are all the concepts we need to know. So, what are all the concepts? We just try to consolidate all the content we have seen in the class. See, what is the current value if you derive it from this expression. I'm just getting current in the purely inductive circuit will be Im sine of omega t minus 90 degree. And from that we are understanding that always in the purely inductive circuit, the current will lags the voltage by 90 degree by the phasor diagram. And what is the power expression we have got in the purely inductive circuit, that is minus Vm Im by 2 sine of omega 2 sine 2 omega t. And if we are plotting the graph for the given power expression, so what we are getting actually, the power is negative at one time, and it becomes positive, and it becomes negative, and it becomes positive, and it will be continuing throughout the process. Right? See how many negatives are there? 1, 2 negatives are there, 1, 2 positives are there. So if you average this power, obviously you will get what? It becomes 0. So all the powers, whatever the powers we are getting in the purely inductive circuit will be reactive power. Why it is reactive power? Since the power is delivered from the load to source here at this portion, and source to load, and then load to source, source to load. So this power never utilized by the inductor, nor utilized by the source. So these are all reactive powers. There is no real power. If it is a real power, then we should get average power. That is the point you need to understand. So many things we have learnt in this particular lecture, and you go through these, it will help you in learning the purely capacitive circuit. Thank you. You go through this. Happy Deepavali. Thank you.